Hello everyone, welcome to our project demonstration. We are the students of Science and Policy Engineering from Computer Science and Engineering Department. Our project title is Smart Waste Segregation System.
Yes, in the current scenario, there are many problems are existing regarding the segregation of the waste. So, improper segregation of the waste at the source leads to environmental pollution and also increased landfill load and a manual health risk. Therefore, we need an automated and intelligent system that can classify and segregate the waste efficiently. And also, waste management is a major challenge due to improper segregation at the disposal point. If any of the municipalities or any of the users they have installed means they didn't segregate the waste correctly. And also, if the bins are fully filled means no one is responsible for that. It will be overflow. And manual sorting is time consuming and it is also unhygienic to the persons. And they will cause some diseases which is risk for their health. To address this, a smart system is required that can automatically and identify and sort the waste using that AI and provide real-time monitoring through the IoT so that overflowing of the waste will not be happen to ensure the efficient collection and resource management. So for the existing problem, we are proposing a solution as an AI and IoT based automated waste segregation system. First, that uses the CNN model to classify the waste images and ESP8266 as a microcontroller for the conveyor movement and a servo based mechanism for sorting and IoT sensors for bin monitoring. The system works end to end with a cloud dashboard for real-time visibility. Our system is modular and all the components are low cost and readily available. The CNN model setup and component selection and hardware testing is easy. After this, let me explain our methodology step by step in a simple way. First, it is an image acquisition. A webcam captures the image of the waste item on the conveyor belt. The camera is placed above the conveyor for a clear, well-lit images. After this, it's image processing. The captured image goes to the laptop or a computer. Here, the MobileNet V2 model pre-processes the image using an OpenCV and prepare it for a classification. After that, classification result transmission. In this, after processing, the model classifies the waste into biodegradable, non-recyclable or e-waste. The classification result is then sent to the ESP8266 microcontroller. Here the sorting actuation will happen. Based on the received category, the servo motor moves the deflector arm. The conveyor belt carries the item and arm pushes into the correct bin. If the received category is detected as a biodegradable means the servo moves forward. If it is a non-recyclable means the servo moves, conveyor moves backward. If it is a e-waste means the servo actuates and the conveyor belt moves forward. After this, the sensor data acquisition, ultrasonic sensors will be installed in all the three of the bins so that we can measure how full each bin is. This helps to avoid the overflow and maintain the smooth functioning. After this, data transmission to the cloud. All the data like a category, bin levels and logs are sent to the cloud using the secure communication. This ensures real-time monitoring from anywhere. In the data visualization, we have installed to that hardware setup also in the OLED display so that user can see what type of waste is detected and we have developed one web dashboard also for the bin status and alerts. Our system is first ESP8266 microcontroller. It is responsible for managing the conveyor movement, sorting mechanism, bin level detection and cloud communication. It serves as the brain of the system by executing all the embedded control logic. It is a primary control unit used in our system. Next, we are using a breadboard power supply module. Provides a regulated voltage outputs necessary for the different components and the system requires both 5 volt and 12 volt supplies for the ESP8266 sensors and OLED display. The power module ensures a stable voltage regulation, and then we are using L293D motor driver To interface these high current motors with the low power microcontroller, the system uses 8 to 90 motor driver. ESP cannot supply the current required by the motors, and also we are using two DC motors. It's a 12 volt. The conveyor mechanism is driven by these, which provide the required torque and smooth rotation speed for the consistent of the movement of the waste items. Then we are using OLED display. In OLED display, it's for the local display and monitoring. It is integrated into the system itself. Then we are using two servo motors here. It's we are using a servo motor, which is used to control the deflector flap position, and we are using for each pins we are using a ultrasonic sensor to detect the waste bin is full or not. It is the web dashboard of our Smart Waste Segregation System. It is essential component for the Smart Waste Segregation System, providing user-friendly interface and real-time monitoring, and also control the entire setup. Here it is categorized into 3 different categories: biodegradable, e-waste, and non-recyclable. The user can detect what are the waste type are filled in that waste bins, and also it is an internet-enabled device. The dashboard displays important operational information such as waste classification result, bin fill levels, and system status. It is a web dashboard of our smart system. The first step is capturing the image of the waste item. We place the webcam at a fixed position above the conveyor so that the waste item passes through the each image capture zone. Like when we are capturing the image of the waste, if it is detected as a biodegradable, it shows in the web dashboard what type of waste is detected and how many type of waste is detected. The hardware takes over the conveyor, moves forward, and the waste is directed into the correct bin based on the classification of the waste. If the waste placed on the conveyor is detected as a non-recyclable, means it will show on the web dashboard like what type of waste is detected and how many waste is detected. After this, in the setup, if you put the waste, the conveyor moves backward and the waste is directed into the correct bin based on the classification of the waste. If this categorized as e-waste, then it will display in the this. In the hardware system, the servo actuates and the conveyor belt moves to the forward, and the waste placed on the conveyor will be directed into the correct bin. Finally, our project demonstrates how AI, IoT, and automation can work together to solve a real-world problem like waste segregation. The system detects, classifies, and sorts waste automatically, making waste management easier, safer, and more efficient. The real-world useful is this system can be used in apartments, colleges, and industries, small or smart cities, to reduce manual effort, improve hygiene, and increase recycling accuracy. It supports cleaner environments and smarter waste handling. In the future, we can expand the system to include the more waste segregation, add higher quality cameras, integrate robotic arms, improve accuracy with larger data sets, and connect this system to municipal waste collection networks. Now, what are the innovations in our project is it combines machine learning based classification, automated sorting, and sensor monitoring and cloud dashboards in a single integrated solution. Through this project, we learned how to integrate hardware and software, handle real-time data, train ML models, and manage IoT communication and solve practical issues like motor control, sensor calibration, and data accuracy. Our smart waste segregation system has a potential to reduce the human effort, improve waste handling efficiency, and contribute towards a cleaner, sustainable, and technology-driven future. Thank you for watching our project demonstration. We hope our work inspires innovative ideas for smarter waste management.